Hello, this is the 8th video on electromagnetism for students of class 6 to 10. Can be used by class 10 students to review. In the previous videos, we have seen that you can generate static electric charge by rubbing material like plastic, glass, PVC. And we also learned that static charge is of two kinds, positive and negative. Opposite charges attract, same charges repel. And we also made a simple instrument called the pith ball electroscope. Using it, we can find out if there is any charge on any object. We take the object close to the electroscope, and if the electroscope deflects, it means that there is charge on that object. In this video, we will see that charge can be transferred to a metal object. So when I rub a PVC pipe, the charge appears on the pipe, negative charge appears on the PVC pipe. I can rub this PVC pipe on a metal cup, and the charge will move from the PVC pipe to the metal cup. So here I have a metal cup, metal vessel made of silver. I have placed it on a plastic pen. So I'm going to use this plastic pen as a handle to lift the metal cup. There is no charge on the metal cup. As you can see, the pith ball electroscope is not deflecting, so there is no charge on the metal cup. So now I take a PVC pipe and I rub it with a woolen cloth, and you can hear the crackling sound, which shows it's charging. So now I rub the PVC pipe onto the metal cup. So when you do this, you can hear again tiny, small crackling sounds as the charge moves. So the charge moves even without actually touching. If you just take it close to the cup, the charge jumps from the PVC pipe to the metal cup. Again, this experiment works well only on a dry day. So check that relative humidity is less than 40% by checking up the weather report. On a wet day, charge leaks very quickly, it doesn't collect. Okay, so now I have transferred enough charge onto the metal cup. Now, how do we know it is charged? We will know now when you take it to the electroscope. So it shows that there is charge on the metal cup. So charge has, okay, now I'm going to touch this with my hand. There's a very tiny sound, clicking sound which, okay, so now you can see the cup has no charge. So the charge moved from the PVC pipe to the metal cup, and it stayed there as long as you held it with the plastic cup. But when I touched the metal cup with my hand, then the charge went away. And the electroscope shows that there is no charge on the cup anymore. So here you can see the charge from the PVC pipe jumps onto the metal cup. PVC pipe is removed. So now when I touch it with my hand, the charge finds a path to go away to the earth. So this way we saw that you can transfer the charge from the PVC pipe to the metal cup, and it will stay on the metal cup as long as you don't touch it. When you touch it, the charge flows away to the ground. So through your finger, through your body, it flows through to the ground. So charge can be transferred to metal objects. It stays there only as long as it is insulated. So I held it with a plastic pen because the pen doesn't allow charge to flow away. The pen is an insulator, does not allow electric charge to flow through it freely. But when you touch it with the hand, then the charge flows away. So now we know why we needed the plastic pen. Otherwise, the charge would not have collected on the cup. It would have continuously flowed away. So, but an ebonite rod or a glass rod retains the charge. We did not hold it with an insulator. It is itself an insulator. We held it in our hand and we charged it, and the charge stayed on the PVC pipe. So insulators retain the static charges. For how long do they retain? For quite some time. Eventually they will leak off into the air, and if it's a humid day, very quickly, but still they stay for some time. So this is what happens. So if I imagine this blue rod as the ebonite rod or the PVC pipe, then when I rub it, there is charge formed on it. And when I touch it with my finger or with the metal cup, then a small portion of the charge moves to the metal cup or to your finger. But the rest of the charge, which is far away, still stays on the insulator because it's an insulator. Charges are not flowing freely through it. So these charges stay there for some time. So if you want to remove all the charge from the PVC pipe or the glass rod, what do? Then you have to rub it thoroughly with your hand. So then all the charge moves off to the ground. Okay, so now we have seen that charge can be charge moves, static charge moves to any metal object. So we are going to now make a test charge. So when we made the pitball electroscope, we saw that the pitball electroscope responds to a positive charge and to a negative charge, to a glass rod rubbed with silk and to PVC pipe rubbed with wool. So the electroscope does not tell you whether it is positive charge or negative charge. It only tells you that there is charge there. Now you want to find out what kind of charge is present on any object. So we need a small metal conducting object which is very light. Okay. So I'm going to take a thermocol bead and cover it with aluminum foil. Here I have a metal cup. I have charged it. I could have charged it with the PVC pipe, or I could have charged it with a glass rod. Okay, so I can, just like I transferred the negative charge, I can also transfer positive charge on a metal object. So I don't know we don't know now which charge was transferred on this object. So in order to check to find out, I first make a test charge. So this is a small thermocol bead which is covered in aluminum foil. I've just wrapped some aluminum foil. So that is the metal object which will carry the test charge. So I'm going to charge this this aluminum foil. So first I use a negative test charge. So this is a charged PVC pipe. So I'm going to touch that bead, aluminum bead. So now that bead has got charged by touching it, transferred, right? So now it has negative charge. So now I'm take it close to the metal cup. So it is not touching the metal cup, it is going away from the metal cup. So that means that the metal cup has negative charge. Because the PVC pipe had negative charge, the test charge is negative, and it is repelling the cup. So that means the cup is negatively charged. Now I can cross check. I remove the charge from the aluminum bead. Then I generate positive charge by rubbing glass with silk. So now the test charge is going to be positive charge. I touch it to the, okay. So it has, okay, so it has acquired positive charge. Now I take it close to the metal cup. See, it's leaning towards the cup. So it's getting attracted to the cup. You see that leaning? It is attracted to the cup. Clearly. So because the test charge is positive and it is getting attracted to the metal cup, that means the metal cup has positive charge. So this way we can use a test charge to find out the nature of an unknown charged object, whether it is a positive charge or a negative charge. So in this video, we have seen that charge can be transferred to metal objects. And when a charged metal object is touched, then the charge flows away to the ground. Insulators hold on to the charge, and because charge does not move through them. And we can use a small light metal bob suspended on a thread as a test charge to find out the sign of any charged object. We stop here.